Hi, I'm Kaviraj from the University of Mauritius, and today I'm going to talk on wireless network planning and management, more specifically into site surveying. First of all, what is a site survey? A site survey is an in-depth examination and analysis of a wireless LAN site to make sure that the wireless LAN can provide its intended functionality and meet the required design goals. You still don't understand it? Let's take a look at this particular scenario. Hey man, I need Wi-Fi in my room. It's an easy task. I need to add a Wi-Fi extender in your room. Some days later, hey man, it's me again. I also needed Wi-Fi in my living room but can't seem to have that connectivity. You should have told me before. Never mind, I will just add another Wi-Fi extender. Some days again later, hey man, now I want Wi-Fi in my kitchen so that I can watch YouTube videos. But your kitchen is next to your living room, isn't it? How come you don't have Wi-Fi? I guess your router is wrongly placed in your living room. To make things simple, I will add another Wi-Fi extender in your kitchen. Can you guess the problem here? I give you 3 seconds to think on it. Got it? Of course, this is not the efficient setting of a wireless network, or even extending the range. While this method may work in individual houses, it is not appropriate for a 10-story building, which can be costly and bulky in terms of equipment. But the question is, how to do it? Well, this is where a site survey is necessary. The A site survey provides a realistic understanding of the infrastructure required for the installation of a new wireless network. It also assists in predicting network capability and throughput, as well as indicating the exact location of access points and power levels required. Let's take a look about the types of site surveys that exist. Firstly, there is a manual survey, and secondly, there is a predictive survey. The manual survey is subdivided into passive and active. Let's see what the passive survey is. Passive surveys are surveys that are performed with a listen-only mode, whereby the survey client never associates to the access point. The client only listens to packets being sent and received on the wireless LAN. It helps to gather information regarding the radio frequency characteristics on the premises by collecting radio frequency measurements such as signal to noise ratio, signal to interference ratio, access point coverage areas, number of access points, frame format, and channel bandwidth. Now let's take a look on what is active survey. An active manual site survey can provide more insight into the network connectivity and its performance. This type of manual survey involves both receiving as well as sending packets to determine the status of the wireless LAN. Information gathered during an active survey are TCP upstream and downstream rate, UDP upstream and downstream rate, UDP upstream downstream loss, TCP upstream and downstream loss, associated access point, and round trip time. There are two main methods used in active surveys. The first one is basic service set identifier method, in which the clients log into an access point, MAC address, and prevents the client from roaming. The second one is the service set identifier, abbreviated to SSID method, in which the client roams between multiple access points. Now we will look at predictive survey. A predictive site survey is a virtual survey of the area that uses modeling techniques to design the wireless network instead of having a person manually going in a building as in manual site survey. In a predictive site survey, the building of the floor plans are loaded into the predictive analysis simulation application survey software, also called radio frequency planning and management tool, used to develop a wireless network. Predictive site survey applications and verification tools can account for building materials, square footage, the number of wireless users, and types of antenna models and other variables in a simulated environment to provide a wireless plan for the facility. The best time to incorporate a predictive survey include when the deployment environment has not yet been built, in order to obtain a budgetary environment for the wireless LAN, and where access to the environment is restrictive. Now we will take a look on the tools used during a site survey. Firstly is the wireless device tools. Wireless device tools can include access points and laptops, which can capture a signal. This signal will be used to calculate the received signal strength indicator, also known as RSSI. However, this method is imprecise as client utilities represent RSSI as percentage of package RSSI over maximum RSSI multiplied by 100. This is why wireless device tools are considered to be rudimentary and should not replace sophisticated tools. Now we will take a look on specialized tools. Specialized tools include dedicated applications which can both send and receive packets, therefore analyzing transmitted data and received data. Some settings can include destination MAC address, continuous link test, number of packets, and packet size. On the right hand side is a list of such tools that you can find on the internet. Another specialized tool is a spectrum analyzer. A spectrum analyzer is a device that scans the radio frequency spectrum and locates potential sources of interference. They do not modify the radio frequency wave, but instead displays a raw and unprocessed signal to have a better visual of the wave. The common measurements of such tool are modulation, distortion, and noise. One particular example is a Cisco Spectrum Analyzer. A third specialized tool is a protocol analyzer. A protocol analyzer, also called sniffer, is a hardware or software that captures packets to decode and analyze its content. Protocol analyzers can fully decode application layer network protocols such as HTTP or FTP. These analyzers can be used to monitor traffic on a network to look for problems and also to watch for particular types of sources of traffic. One such example is Wireshark. Now we will look at documentation tools. Documentation tools is important in order to document all the collected information. This information can then be used to be put into a database. The report should include but not limited to the following: the purpose of the report, the survey methods used, the radio frequency coverage details, throughput findings, sources of interference, problem zones, marked up facility drawings with access point placement, access point configuration. So, what are the steps in performing a site survey? Firstly, gathering data. Gathering data involves examining business requirements, defining physical and security requirements, gathering site-specific documentation, documenting existing network characteristics, analyzing technical requirements. The second step is to actually perform the site survey. The third step is an optional one based on your client requirements, that is to perform an outdoor survey if they need Wi-Fi coverage outside the building. And the fourth step is to actually create a site survey report, which is important for documentation. Well, I hope you are not bored too much. These concepts were necessary before performing a site survey. Are you ready to take a look on how to use a wireless network planning tool? Then let's go.
To perform the predictive site survey, we will be using Extreme Cloud IQ Connect, which is an online wireless survey tool. We just need to create an account to be able to use this tool. After logging in, you will be redirected to this dashboard. Just click on ML Insight and follow the following paths. And then you need to create a new map, add some information, and then you can upload a floor plan. For this demo, I will be using an office floor plan, which I have already downloaded. Now I will need to size the floor plan in order to make it scale properly. I will use size manually and use this 2 crosshair to position it on the longest width of the floor plan. and I will change this into meters and set this, let's say, to 100 meters long, and then apply. As you can see, it has already given us a scale, a proper scale. Now that we have the floor plan here, we need to have some modifications to it. We need to tell the software where we need the coverage area. That is, we need all the access points inside the building or also outside. For the sake of this demo, I will be placing the access points only inside the building. So I will draw the perimeter here. Now that I have defined the coverage area, I will need to add the different types of walls that there are in this building. Let's say we have some concrete wall which have 12 decibel attenuation. So let's say this is the wall. Let's say we add another type of wall, let's say brick wall. And let's add another dry wall here. Okay, so that's it. We have added information, enough information, but let's say we will just go to plan devices to place the access points. You can place the access point manually and visualize them, but there is another interesting tool which is the ML Insights, which will automatically place the access points. We just need to set the proper settings, let's say high speed connectivity, and click on auto place to place the access point. As you can see, it has placed the access point and has used 10 access points for this plan. To better visualize this, you can go to view heat map to actually view the coverage area. You can see the RSSI here. It has done a pretty good job in covering the whole building. You can view also the signal to noise ratio and other important information. Let's stick to RSSI for this part. And as you can see, it has done a pretty good job in covering the whole area, and you can actually visualize. You can also tinker with other information, like if you need 2.4 gigahertz or 5 gigahertz and other channel widths, but this is just for demonstration purposes. One important aspect that you can do is you can just export this document into a PDF so that you can show to your client, and I will show you how it looks like. As you can see, a report has been generated, and you can actually show to your client how many access points that approximately your floor will take. This can be used in predicting the budget, etc. of the wireless network. As you can see, it also tells you the model of the access point and also the type of network. So that's it for the wireless network tool, which can be used for predictive site survey.